There are things in this universe, so massive, so powerful, that they don't just exist, they redefine reality itself. Imagine a place where gravity is so strong that even light cannot escape. Where time slows down and space bends like fabric under pressure. A place so dark that it doesn't just hide what's inside, it erases it from the universe forever. Now imagine something even more terrifying. Not just a black hole, but a black hole so enormous, it could swallow our entire solar system, and still have space left. A monster that shines brighter than entire galaxies, visible from billions of light years away. This is not science fiction. This is real. Somewhere, deep in the cosmos, exists one of the largest black holes ever discovered. A cosmic giant, 66 billion times more massive than our Sun. Its name is TUN 618. And what you're about to see will change the way you look at the universe forever. TUN 618, the darkest giant in the universe. There are objects in the universe so vast, so powerful, that they push the boundaries of imagination itself. Not just larger than planets, or stars, or even galaxies, but forces so extreme that they reshape reality. Places where gravity doesn't simply pull, it bends space and time. Where the laws of physics begin to blur, and where even light, the fastest thing in existence, can never escape. These are not ordinary objects. They are the most mysterious and terrifying phenomena in the cosmos. And among them, one stands above all. An abyss of infinite darkness, wrapped in blazing energy. A monster so immense it dwarfs nearly everything we've ever discovered. Its name is TUN 618. Milky Way the discovery. TUN 618 lies billions of light years away, near the boundary of the constellations Canes Venatici and Coma Berenices. But when it was first discovered in 1957 by astronomers at the Tonantzintla Observatory in Mexico, it didn't seem special at all. Through early telescopes, it appeared as nothing more than a faint blue point of light. Just another distant star lost in the vast ocean of space. There was nothing dramatic about it, nothing that hinted at its true nature. It was catalogued, recorded, and almost forgotten. But science has a way of revealing what the eye cannot see. Years later, with more advanced instruments, astronomers began to study this object in greater detail. They analyzed its light, not just how bright it was, but how that light was structured. This technique, known as spectroscopy, allowed them to break the light apart into its component wavelengths. And what they found changed everything. The light from TUN 618 was not normal. It was shifted, stretched, distorted in a way that suggested immense speed and distance. This was no ordinary star. It wasn't even a star at all. It was something far more powerful. The blazing core of a distant galaxy, powered by a black hole of unimaginable size. A message from the early universe. TUN 618 is not just far away. It is so distant that the light we see today began its journey over 10 billion years ago. Think about that. Every photon reaching your eyes left this object when the universe was still young. When galaxies were just beginning to form. When the first generations of stars were lighting up the darkness. In a sense, looking at TUN 618 is like looking back in time. We are not seeing it as it is now. We are seeing it as it once was, a snapshot from the early universe. At such distances, TUN 618 itself cannot be directly resolved. We cannot see its structure clearly. Instead, we detect its presence through its glow, an intense, radiant signal that cuts across billions of light years. And that glow comes from one of the most powerful phenomena in existence, a quasar. The power of a quasar, Quasars are among the brightest objects in the entire universe. They are not stars. They are not galaxies. They are something far more extreme. At the center of a quasar lies a supermassive black hole, a gravitational monster devouring everything around it. Gas, dust, even entire stars are pulled inward by its overwhelming gravity. But this process is not quiet. As matter falls toward the black hole, it begins to spiral. Faster and faster, forming what is known as an accretion disk. Within this disk, particles collide. At incredible speeds, friction builds. Temperatures rise to tens of thousands, even millions of degrees. The result is an explosion of energy. Radiation is emitted across the entire electromagnetic spectrum. From low-energy radio waves, to visible light, to high-energy X-rays and deadly gamma rays. This makes quasars incredibly luminous. So bright, they can outshine entire galaxies. Imagine a single point in space radiating more energy than hundreds of billions of stars combined. That is the power of a quasar. But the spectacle does not end there. Within the chaos of the accretion disk, magnetic fields twist and tangle. Energy builds until it is violently released. From the poles of the black hole, massive jets of plasma are launched into space. These are known as relativistic jets. They travel at speeds close to the speed of light. And they don't just extend for a few thousand kilometers. They stretch for millions of light years. Longer than entire galaxies. These jets carve through space, pushing away gas, disrupting star formation, and reshaping the structure of their host galaxy. A quasar is not just a light source. It is a force of transformation. A light that outshines galaxies. Ton 618 is one of the most luminous quasars ever discovered. Its energy output is almost beyond comprehension. It shines with the power of over 100 trillion suns. Let that sink in. If Ton 618 were placed at the center of our Milky Way galaxy, it would dominate the sky. Every star you see at night, every point of light, would be overwhelmed. Ton 618 would outshine them all. It would appear brighter than the full moon. More than 20 times brighter. The night sky as we know it would disappear. Darkness would be replaced by a constant, blinding glow. The colossus within. At the heart of this brilliance lies the true monster. The black hole itself. Ton 618's black hole has a mass of approximately 66 billion suns. To put that into perspective, the black hole, at the center of our galaxy, Sagittarius A*, has a mass of about 4 million suns. Ton 618 is over 16,000 times more massive. It is not just large. It is colossal on a scale that is difficult to comprehend. Its event horizon, the boundary beyond which nothing can escape, stretches across roughly 400 billion kilometers. That's large enough to engulf our entire solar system. From Mercury, to Earth, to Jupiter, all the way out to Pluto. Everything could fit inside, and there would still be space left over. Where reality begins to break. Approaching Ton 618 would be unlike anything we could ever experience. As you move closer, gravity intensifies. Space itself begins to warp. Light bends around the black hole, forming a glowing ring known as the photon sphere. Here, light can orbit the black hole, trapped in a delicate balance between escape and collapse. Time itself begins to change. Near the event horizon, time slows dramatically. Seconds for you could become years for someone far away. To an outside observer, you would appear frozen, suspended in time, hovering at the edge of the black hole, never quite crossing it. As you move even closer, the universe around you would begin to change color. Light loses energy as it climbs out of the gravitational field. This effect is called gravitational redshift. Bright light would stretch into deeper wavelengths. Blues would fade into reds, reds into darkness. It would seem as though the black hole is draining the universe of color. Beyond the event horizon, there is no return. No signal can escape. No information can be sent. Only one fate remains: collapse. At the center lies the singularity, a point of infinite density. A place where our understanding of physics breaks down completely. Where the known laws of the universe no longer apply. Brain the mystery of its growth. How does something like ton 618 even form? Black holes are believed to begin as the remnants of massive stars, or from the direct collapse of enormous clouds of gas in the early universe. Over time, they grow. They feed on surrounding matter, pulling in gas, dust, and stars. They merge with other black holes, slowly increasing in size. But ton 618 breaks the rules. To reach 66 billion solar masses so early in cosmic history, it must have grown at an extraordinary rate, far faster than our current models predict. This raises a profound question. Are our theories incomplete? Did conditions in the early universe allow black holes to grow much faster than we thought? Or did ton 618 begin its life already massive? We don't yet know, and that mystery is what makes it so important. A window into the past. Quasars like ton 618 are not just cosmic giants. They are also cosmic time capsules. Because they are so bright, their light travels across vast distances, passing through clouds of gas between galaxies. Along the way, this light carries information. By studying it, astronomers can learn about the chemical composition of the early universe, the distribution of matter, and how galaxies formed and evolved in their earliest stages. Ton 618 is both a destroyer and a guide, a force of unimaginable power that also illuminates the hidden structure of the cosmos. And when we look at it, across billions of years, we are not just observing a distant object. We are witnessing the universe itself in one of its most extreme forms. A place where reality bends, where time slows, where light dies, and yet, in that darkness, we find something extraordinary. A deeper understanding of where we come from, of how the universe evolved, and of just how vast and mysterious it truly is.